PLSQL, Programming Language for SQL. What is PLSQL, or Programming Language for SQL? SQL, or Simple SQL Commands, not PLSQL, is a scripting language. It's a simple scripting language. PLSQL is effectively an enhanced version of SQL. How is PLSQL an enhanced version of SQL? PLSQL is enhanced to the point that it becomes a programming language. PLSQL is a programming language because it allows dependencies between following commands. And it has modular structure. What makes PLSQL a programming language? It has modular or block-like structure. There is a form of programming design which involves modularity. Now, what modularity means is that you can include blocks of code within other blocks of code. In other words, one chunk of code can call another, and so on. So you can embed modular structures or blocks within other blocks up to any nested level. The nested levels are generally finite in any programming language, but they're generally enormous numbers. It's not really much to worry about. What you can effectively create is a hierarchy of code blocks where code blocks call other code blocks, which call other code blocks. So a block or modular structure would look something like the diagram shown on the right below. Exception or error trapping is also very important in a programming language. Exception tracking in PLSQL is fairly sophisticated in that exceptions are localized to code blocks. When there is no exception in a block or a specific exception is not handled, an error or exception is passed upwards to the calling block. If an exception occurs at the highest level of your coded or written PLSQL code, the error will be passed up to the application which is executing PLSQL, such as SQL+. The point to note is that exceptions are generally always handled. They're always dealt with. It's a poor programming language that simply remains executing when a horrible error has occurred, because all sorts of other unpleasant things could happen. PLSQL enforces strict data typing, what is called strict data typing. Generally, scripting languages do not enforce strict data types and data typing, and generally programming languages do. For instance, JavaScript, VBScript, a lot of the front-end web-like programming languages do not enforce strict data typing. Perl, for instance, can be selected to enforce strict data typing, but it does not have to. PLSQL enforces strict data typing. PLSQL allows creation and manipulation, manipulation of variables. PLSQL has a number of programming controls. By programming controls, we mean things like if statements, case statements, for loops, etc. Anonymous procedures. Once again, an anonymous procedure is a procedure without a name. It is not stored in the database because it is a procedure which is used only once. In other words, it cannot be executed again. Here is a syntax diagram of the anonymous procedure syntax. Here we have a variable declaration section. It's optional and it's listed under the declare section. The / command at the end will submit the procedure to the parser, compile it, and then execute it. The block declared between the begin and end statements is the executable code. This part here is actually demonstrating that we can place a block within a block, including its own exception trap loop. Here we can see the exception traps highlighted. The raise statement is optional. What it does is it actually passes the exception up to the parent or calling procedure, be it another procedure you have written or your application. These are called exception traps. They trap exceptions. Now I'm going to demonstrate some very simple anonymous procedures. Here is an anonymous procedure highlighted here. I'm using DBMS output within the procedure to output some information, so I need to set server output on in order to get the output from DBMS output to appear in SQL+. I'm going to copy this code, which is actually doing a for loop, counting from 1 to 10, and simply outputting where the count is. Here's the exception. Generally, an exception trap has a rollback, especially if you have any kind of SQL database change activity, such as DML statements. In this case, it's not strictly necessary, but we'll put it there anyway. Let's copy and paste this procedure and execute it. And you can see we have a count from 1 to 10. Very simple. Here's another slightly more complex anonymous procedure. It builds what's called a cursor, which we'll get onto later, and then it does things to the supporting ACT table based on the ACTs and shows that was selected to create supporting ACT records. This particular anonymous procedure is part of the schema scripts that we use to create the concepts schema database and all its data. Don't worry about that for now. I'm just showing you that it's a little bit more complex than simply something such as this. A named procedure is much like, or if not exactly the same as an anonymous procedure, other than the fact that you give it a name and you store it in the database, and it becomes what's known as a stored procedure or a database procedure. The point about a stored procedure is that it is executed against the data on the Oracle server. In fact, in the later versions of Oracle, stored procedures can be written in both PLISQL and in Java. Java stored procedures will actually execute on the server within the database kernel inside an Oracle Server Database Java virtual machine. To get performance out of Java stored procedures, they can actually be recompiled and reconstituted into C-compiled code using a piece of software which was released in Oracle 8i called the Java Accelerator. Another block type piece of modular code in PLSQL is a function. This is very simple really. A named procedure is a procedure, a function is a function. Now if you know anything about programming at all, you know exactly what the difference between these two are. Assuming that you don't know anything about programming, a stored procedure or named procedure is a chunk of code that allows you to put parameters into, but you cannot return a value from it unless you return a value through a parameter. A function in programming theory is a chunk of code that allows you to return one or more values as well as passing in parameters. The real difference between procedures and functions are that functions are compiled and can be embedded by name within other functions. In other words, a function forms what is effectively an expression. A stored procedure could not, for instance, be buried within an expression such as a select statement because it does not return a value. A function could. That's the value of a function. We've already seen a lot of Oracle built-in functions, group by functions, etc. These are functions. In this case, for modular PLSQL, you would be creating user-defined functions. Another part of PLSQL is triggers. Triggers are a very interesting thing. In some relational databases, triggers are called rules. In some relational databases, rules and triggers are used to create expert-like systems. Triggers were initially used in Oracle to validate referential integrity between primary and foreign keys in schemas. They can still be used to that effect, but now the better method of coding referential integrity is by using constraints. Some programmers may find it easier to use triggers rather than constraints. However, it is generally accepted practice that triggers are about 10 times slower than the use of constraints. So if you're looking for performance, use constraints and not triggers when coding for referential integrity. A trigger is really what is effectively a database event. It means that something happens in the database and it does what is called, it fires the trigger. In other words, it executes the trigger because something happens. Say a user went and inserted a row into a table which has a type of trigger on that table called an insert trigger. The trigger will detect that insert into the table and it will start executing based on the fact that something was done to that table. That's what a trigger is. Packages are used in Oracle to package stored procedures and functions together in logical packages. There are a number of benefits to using packages. We'll go into those later. Parameters are extremely important, obviously, with procedures and functions. Parameters are passed into procedures and functions to affect the type or the nature of processing within those blocks of code. In procedures, parameters can actually be passed back into the calling procedure, generally as what are called by reference variables. This is something we'll get into later on as well. Named procedures. A named procedure is a stored or database procedure. It has a name, and it is stored in the database permanently. Since it's stored in the database permanently, it can be re-executed, it can be executed again. Here is the create procedure syntax. When creating a procedure, if you simply type create procedure, etc., etc., if the procedure already exists, you will get an error. In order to recreate, alter, and recompile a procedure which already exists, you simply type create and the optional or replace procedure. Parameters in procedures require definition of parameter name plus what type of parameter they are. An in parameter is passed in by value, an out parameter is passed out by value. By value we mean that the actual value is passed in and out of the procedure. An in-out parameter is actually passed out and in by reference. In other words, you pass in a pointer to memory where the value is situated. Typically in-out parameters are used for things like arrays, by reference array variables. Every parameter must have a data type defined. Note that data types, when passing parameters into procedures in PLISQL, are generally more general than the very strict types, such as varchar2s will be passed in simply as varchar2 rather than varchar2 with a length of the variable. Note how the procedure name and parameter definition is preceded by the keyword is or as, which is followed by a block structure. An exception trap can be included, plus at least one SQL command or PLSQL statement. A PLSQL procedure without any PLSQL commands between the begin and the end block will simply fail to compile. It will give you an error. Here's the alter procedure syntax. This is very simple. Alter procedure syntax is generally used simply to compile a procedure again. The drop procedure syntax is also very simple. You simply drop the procedure. Drop procedure command will completely remove a procedure from the database. Let's go and take a look at some examples. If you can remember, in a previous course, we did a price multiplier recalculation. What this procedure will do is places that calculation into a stored procedure. The benefits are twofold. The code is in one place, it's in the database. It's not coded ad hoc or pasted ad hoc into SQL+. It's also executed on the server. In fact, there is a third benefit which is not necessarily always the case, but PL/SQL procedures generally will execute faster, mainly because they're on the server. They'll execute faster than they would on a client machine using SQL+. All this procedure does is takes in 4 parameters, namely a venue and an act name, a show date, and a price multiplier. Note that each show is listed on the table called show and is referenced through the venue and act tables by a show ID. Since the show ID is an internal unique identifier, we don't actually know what it is, but we do know what the venue and act names are. What we do then is we update the show table, and we set the price multiplier equal to the price multiplier update, the change in the price multiplier column, and we restrict the record we're updating to a unique show by specifying the show venue ID as being a subquery based on the name of the venue. The act is linked to a subquery based on the name of the act, and we specify an exact show date equal to an exact show date value, which is passed in as a parameter. All we're doing at that point is simply outputting the values that we've changed with DBMS output. Let's copy and paste this procedure into SQL Plus and run it. So we've created the procedure. The front slash command has actually created and compiled the procedure. Now what we'll do, in order to make absolutely sure that our procedure is correct, is I'll show you the alter procedure command, which will compile the procedure. If there are errors in the procedure, you would simply type the command show errors, and it would show you any errors that the compiler had detected. And then you could take action to correct your code and sort the problem out. Now what I'm going to do is I'm going to try to find some rows to change. First of all, I'm going to set columns so I can see the details coming out. I'm going to set the pages to 80 lines so that I don't get headings all over the place. And then I'm going to run a join between the act, show, and venue that validates against the ticket table. So I'm trying to find act, venue, show combinations that actually have tickets. There's no point changing a price multiplier for shows that don't have tickets, not at this stage anyway. So let's run this code. The result of that query gives me 42 shows which have tickets in the ticket table. So now what I'll do is I'll go back to my script, and I already set up some shows that I wanted to change. I just wanted to show you where that information came from. So I'm going to change price multipliers for this particular venue and for these particular acts with shows on these particular dates, and we'll see the result that comes out. Once again, I'm setting server output on, I'm executing the commands, and I'm setting server output off because I'm using DBMS output. Let's run that. As you can see, we have price multiplier changed to 1.25 for sticks at Compact Center on 14 December 02. If any errors were detected, it would have given me an exception for one or more procedures and continued executing the next procedure. Here I've got the description for each change. So that's fairly simple. Since I don't want to keep that procedure in the database, I'm simply going to drop it again. A function is a stored function. Functions are very much like stored procedures. They have a name, they're stored in the database, they can be executed again. The only difference is that a function returns a specific value. In other words, it can be embedded and executed in a nested fashion within an expression. Create function syntax. As with create procedure, you use create or replace to replace an existing function. If the function doesn't exist, it doesn't matter, it executes the create option. Again, the parameters in, out, and in, out are exactly the same as with a procedure. Passed in by value, passed out by value, and passed in and out by reference. The data types have the same restrictions in that varchars will be passed in as varchar2 without the specifier at the length of the varchar2. The difference with the function is that it has a return data type or a return clause. Here's the alter function syntax, which simply does a compile exactly the same as the alter procedure syntax. The drop function syntax is the same as procedure, except that it drops a function. Let's look at an example of a function. We've seen this function before. This is a function that converts Fahrenheit values to Celsius. This function is required to return a value because I'm executing it from the command line inside a DBMS output exec procedure. When executing any kind of procedure outside of another PLSQL block or procedure, you use the exec, or short for execute command. It means execute the procedure. So all this function does is create or replace the function F to C, passes in the number Fahrenheit, defaults it to 0, and returns a number. Here is the function. It's doing a round, Fahrenheit minus 32 multiplied by 5 over 9, and it's rounding to 0 decimal places. The key to the function is this return statement. Note that everything is embedded on a single line in this function. So let's simply create that function and use the alter function command to compile it. And now let's go and execute it with this code. Again, I'm setting server output on, and then additionally in this function I am enabling the buffer for DBMS output text to be 1 million characters. It's a bit excessive for this function, but if you have a lot of stored procedures outputting a large amount of DBMS output within the procedure, if the buffer exceeds 1 million characters, your output will actually stop and it will crash the procedure it's in at that point in time. So be aware of how much output you're actually sending to the screen with DBMS output. Let's copy this and run this in SQL+. And as we can see, 50 Fahrenheit is 10 Celsius, 70 Fahrenheit is 21 Celsius, 90 is 32, 110 is 43, that's pretty hot, and 32 Fahrenheit is 0. So the function is running correctly. Let's go back to here again and simply drop the function since we don't want it sitting in our concert schema. Packages in PLSQL. A package is a concept whereby one can place multiple functions and or procedures into a single chunk of code. There are certain advantages. The first one is in terms of advantages in tuning. A database administrator can actually take a package and pin it into memory. All this means is that the package will not be parsed and compiled every time it's executed. Packaged code is self-contained within applications. Obviously that depends on how you package your procedures. In other words, what procedures and functions go into which packages. Obviously the code is better organized because you can split between applications, you can split between different types of functionality. A package has a name, so therefore it's stored permanently in the database. Being stored permanently in the database is obviously having the advantage that it can be re-executed with ease from anywhere. Packages have a very specific structure. A package is divided into a definition section and a body section. These are two distinct pieces of code. We'll see an example in a minute. The body can't exist without the definition, unless the body has absolutely nothing in it. The definition defines procedures and functions and potentially global variables, and the package body contains the actual code for those procedures and functions. Here's the create package definition syntax. The definition, remember, is not the same as the body. The definition simply contains procedure, function definitions, and potentially global variables. What I mean by global variables are variables which are global to the package. They are not accessible from outside the package. Most programmers understand variable scope. Variable scope means that a variable is available within a certain structure or within a certain block of code. In the case of PLSQL, between a begin-end statement. In the case of a global package variable, that variable is available to any function compiled within the body of the package. Once again, create, the or replace option will allow recompilation and replacement with new code of a package already existing in the database. Again, the data types are more general than in normal SQL. The package definition contains simply procedure and or function definitions. What I mean by definition is that it will simply say procedure, list all the parameters and their data types, plus any return values. That's what the definition is. Very simple. We create package body syntax. The package body is the part where all the actual real live code for all the functions and procedures as defined in the definition section are actually created and coded. Again, the syntax for creating or replacing is exactly the same, except that you now have the keyword body in there. Again, you can have global variables, and they have the standard PLSQL data types. Note that parameter data types in PLSQL are the restricted data types, not data types declared within PLSQL itself. You can declare varchar2s with a data length inside a PLSQL stored procedure. The restricted data types only apply to parameters. Within the package body, we have specific procedures and functions, and this is the syntax. It simply says procedure or function lists the parameters is as, and then the PLSQL code is contained between the begin and end statements. The alter package command is very similar to the alter commands for both procedures and functions, other than the fact that you have the option of compiling the whole package, including definition and body, or just the specification, which is what I call the definition, or the body only excluding the definition. The drop package syntax is just the same. You simply say drop package and then the package name. Let's go and take a look at some examples. Here I have a very simple example of a package called utilities, which I created containing a divide function, a percentage function, and a suppress zeros function. This is the definition. This is the body. Let's go and create the definition and compile it. And that compiles fine. Now let's look at the functions. All this does is a somewhat slightly more complicated version of division, in that if the denominator, which is the number underneath the division sign, is 0, we return a 0 as a result of the division. As you know, any number divided by 0 actually gives you an undefined result. A computer will give you the same result as well. Dividing by 0 usually results in horrible errors on computers, so you want to be very careful not to do it. Percentage function simply uses the divide function to divide the numerator by the denominator, multiplies it up by 100, rounds it to 0. If the result is 0, it returns null, otherwise it returns a character format version of that percentage figure. This formatting will output a number of 0% as 0% with both characters in it. If an exception is thrown here or here, it will simply return 0 as well. The suppress zeros function will simply ask a number if it's 0 and suppress the zeros by simply returning a null value. Very simple. Let's copy and paste the package body, create it, and compile it with the alter package command. And everything seems to be okay there. Now let's simply run some examples. So I'll just copy and paste all these examples. One point to note, the package is called utilities. A procedure inside that package happens to be called divide. The way to access that procedure is by referencing it as package name dot procedure or function name. As you can see, all these are the same. If I was to execute a procedure such as divide from the function percentage, which happens to be in the same package, I do not need the package dot prefix, since we are in the same package. So, once again, let's copy and paste these examples and run them. Triggers. What is a trigger? A trigger is a coded reaction to a database event. An event causes the execution of a trigger, which can be specified within the trigger. Triggers can be used for referential integrity. It's not recommended. It's better to use constraints. It's much, much faster to use constraints. They can be used to log events, for instance, database events. There is a whole section in Oracle on auditing, which is really database administration, but auditing is much more efficient than using triggers for event logging. Quite simply put, triggers are really rules. Rules have been used in some relational databases in the past to create expert systems. Expert systems react to certain database events or states in order to assess various paths of execution. Triggers can be used for something like that. They can be used for referential integrity and event logging. Quite often triggers will be used in applications where most of the people working in the applications are more programming oriented and they know much more about writing PLSQL code as opposed to constructing constraints for referential integrity and setting up Oracle auditing. Triggers do have their uses. The create trigger syntax. Once again, create or replace. Replaces a new procedure or simply creates if it doesn't exist. Trigger is executed and defined as being before, after, or instead of. As we can see from the callout, a before trigger is executed before an event occurs. Even though, for instance, we say insert a record, the insert command has begun to execute, but it won't make any changes until the trigger has been executed, because the trigger is specified as to be executed before an insert event is actually performed. After is the opposite way around. It occurs, for instance, after an insert statement is performed. Instead of applies only to views and is really an instead of reaction as opposed to, for instance, inserting into something. The trigger tells it not to insert but to go and do something else. The something else is contained within the PLSQL code of the trigger. A trigger can be before or after or instead of, and can be a combination of detection of insert, update, and delete events. In other words, you can say insert, or you can say insert or update, or you can say delete, etc., etc. Any combination of those three. A trigger has a special piece of syntax called referencing, which allows you to change the way that old and new values are represented. This is not really necessary to use, but within a trigger, as in within expert systems built by relational database rules, you can generally reference a value in a column as two values, as the value before it's been changed and the value after it's been changed. So you would reference that value as old.column_name or new.column_name. For each row implies a trigger is executed for each row for which it is executed. The when condition actually applies a trigger firing SQL filtering condition. What it means is that if you execute an insert statement and it causes a trigger to fire, if the insert statement, in terms of whatever it's changing, fails the when condition, the trigger will simply abort and carry on and do the insert statement without executing any PLSQL code within the trigger, that is. Alter trigger syntax. A trigger can be enabled or disabled. It can actually be renamed, and it can be compiled. Enabling and disabling are interesting. You can create, compile, and store a trigger in the database, and you can actually either permanently or temporarily disable it. Obviously, if you want to enable it again, you'd execute alter trigger enable. And we've already seen compile. The drop trigger command is very simple. You simply type drop trigger, trigger name. Now I want to demonstrate how triggers work, or not necessarily how they work, but the effect they have. What I'm going to do is I'm actually going to create a table called events, where I'm going to store things based on things that happen in the database. Database events will fire a trigger on this table, which will cause an insertion into the event table. Quite simple. So I'm going to create or replace a trigger called category, which says after insert or update of name, parent ID, or delete on category for each row, go and run this command. It means that whenever I insert a record into category, or I update a record in category, changing the name or the parent ID, we don't want to change the primary key, or we delete a row in the category table, this trigger will be executed, and it will insert this row into the events table. One very important thing to remember about triggers: you cannot include, commit, or rollback transactional control commands in triggers. Why? Because a trigger is not supposed to end a transaction, because it is triggered by part of another transaction. You can't have 6 insert statements within a single transaction and then commit within the trigger and expect to be able to roll back at the end of those 6 transactions. Take, for instance, these 2 transactions. This is insert into category, update category, and delete from category. They will all execute the trigger. But I don't have a commit command anywhere here, which means I don't want to store it. What it means is that these three commands are all a single transaction. If there was a commit command in here, it would simply nullify this whole transaction, because this delete could be dependent on this insert, which in fact it actually is. Therefore, I wouldn't want to commit until the end of it. Commit and rollback inside the triggers are not allowed for a very good reason, and that's the reason. So, that can cause other problems, because triggers can fire other triggers. What would happen if this happened to be an insert into the category table? So, this insert would fire this trigger. It would execute an insert in the category table, if this was a category table insert, which would in turn fire the same trigger again itself, so it would recurse infinitely into this trigger. Big problems can occur with triggers where programmers simply lose track of what trigger is firing what trigger. If you have enormous numbers of triggers in Oracle databases, in fact any relational database, you can end up with serious problems as a result of having lots and lots of embedded triggers. Not only triggers that fire other triggers, but sometimes even triggers that fire each other or loop back through other triggers to fire each other again. It can get extremely complicated. Not only are triggers very slow for implementing things like referential integrity and what I'm doing here, a very simplistic form of auditing, they can actually cause such serious performance problems that it can simply kill your database. Be very careful programming a lot of triggers. You can get very serious problems. Now, let's create this events table. Here's my events table. Let's go and create this trigger. The trigger is there. Let's copy and paste these statements. Now, I could have actually typed alter trigger, category, compile, to demonstrate the alter trigger command. Now I'm going to copy and paste in my insert, and I think I typed a character in there I shouldn't have done, so we'll simply copy and paste this again. And we've got one row created, one row updated, and one row deleted. What's next in my script file? Set the column on the event file so that I can see what's going on, because it's 128 characters, that's quite a lot, and select everything from the event table. And as you can see, we have 3 triggered events, which is what the trigger said I should do. Simply go and insert a value into the event. Description is said triggered event on category. Note, the event date has a default of sysdate, so it doesn't need to specify that date field, unless of course the date and the event fields were actually in the other order. Well, then I would need to specify the date to get that description in. That's besides the point. We've gone over that in the past. Now, let's go and change the trigger. Or, moreover, let's add some different triggers. What I'm going to do is I'm going to split that single category trigger into 3 separate triggers. One called category insert, one called category update, and one called category delete. Obviously this one is activated after insert on category. This is activated after update, and so on with the delete on after delete. And obviously we're going to get a different response. What I'm trying to do is make the description in the event table more descriptive. Insert, update, delete, so I know what exactly has happened. So let's go and copy and paste these 3 triggers. I typed the wrong character there, so let's go back again. Copy and paste these 3 triggers. Trigger created, trigger created, trigger created. Note, I can run the alter trigger and specify the trigger name and compile it. I don't have to, because actually creating or replacing the trigger actually creates, passes, and compiles the trigger all at once. We don't need to worry about that, so we won't execute the alter trigger command. Now, what I actually have in my database now here's something interesting with triggers. I haven't got something executing itself But I've got the category trigger executing and all these insert, update, and delete event triggers executing. So I could go and drop the category trigger, but I'll choose not to because perhaps I'll need it later. Unlikely, and I'll alter that trigger and I'll simply disable it. So there will be no events produced on the initial trigger I created, which is the category trigger. I'm now going to detect the insert, update, and delete events on the category table separately. So now I'm going to run another set of insert, update, and delete commands on the category table, and I'm going to select everything from the events table to see exactly what the trigger has created in my events log for me. So let's paste this in here, and I've got row created, updated, and deleted, and consequently, as a result of the triggers firing in the appropriate places, I have a triggered event on insert, update, and delete respectively. Variables and types in PLSQL. What can we look at as far as variables are concerned? First of all, when setting a variable inside a PLSQL block, the variable is set using := notation as shown here. Variables and parameters are all referred to by their own names. Some database languages require that you put colons before the variable name. That is not the case in Oracle. As you can see, parameters, numerator and denominator, are referred to as numerator and denominator, and the locally declared val variable is referred to as VAL. The scope of variables in PLSQL. As you can see from this diagram, var1 and var2 are actually accessible or within scope throughout this entire block between this begin statement and this end statement. Vars 2 and 3 are declared for this block only, inner block 1, and they will actually override any definitions of parent blocks. In other words, the definition of var2 will override the definition of var2 from the outer block. What this means is that var2, being declared as having local scope for this inner block 1, can be changed in inner block 1. Once inner block 1 has completed, that particular declaration of var2 disappears. Therefore, when inner block 1 has completed, the outer block version of var2 will again be in scope and be available and have the value that it had before passing into inner block 1 and redeclaring var2. Perhaps redeclaring is the wrong word. As far as variable scope is concerned, in any programming language, you do not redeclare variables inside blocks where a variable is redeclared as being somewhat different inside a called block or function. It simply has, for instance, in inner block 1, var2 has a temporary status. Once you finish inner block 1, the previous definition and value of var2 from outer block will actually take over again. In inner block 2, var1 actually temporarily overrides the value and the definition of var1 from the outer block. At the end of outer block 2, the initial outer block definition of var1 will again be reinstated with both its definition and value. It's very important to understand variable scope in any programming language. Data types in PLSQL. There are various data types used in PLSQL which are in addition to those used both in create and alter table commands for creation of column data types in tables, and in ISQL and SQL Plus and SQL Plus worksheet. PLSQL has its own specific data types which are somewhat more refined and expanded, plus there are other data types which exist which don't exist in any other part of PLSQL, such as the Boolean data type. A Boolean data type simply contains a true or false value. In other words, you can ask it a question and say if Boolean rather than simply saying if Boolean equals something. Let's take a look at an example use of the Boolean data type. Here we have a procedure which I'm going to copy into SQL Plus and compile. Then I'm going to execute it. I've set the default value of this Boolean variable to true, which means that as soon as it's created or accessed, it gets a value true. Therefore, when I execute this procedure, since it's true, in other words, if I evaluates to true, it will output this line and give me a result that says testing. So I'll now go in exec or execute the test procedure, and I get the result that says testing. Let's go and change this, because we can do the same thing by simply asking the Boolean variable if it is true, as in if I equals true. This will work as well. Let's copy the exec test command, recreate and replace the procedure, recompile it and re-execute it, and I get exactly the same result. In other words, either this syntax or this syntax is fine as far as PLSQL is concerned. Type and row type. As you can see from this picture here, Oracle will allow you to use %type and %row type to declare variables and record types against the structures of Oracle database tables. Here I've got three separate variable definitions for the declare section of an anonymous procedure. Here I've defined the variable called I as being an integer. I've defined a variable called category as being of data type category dot name %type. What happens is that the category variable becomes exactly the same type as the field or column called name on the category table. Last line defines categories, which is actually something called a record, which is an exact copy of the structure of one of the rows in the category table using category %row type. We'll see more on those in a minute. Type. You can create a type in Oracle. A type is like a class structure where you can use it to create user-defined structures, both inside and outside of PLSQL, such as in tables. As you remember, we discussed records when we were looking at %row type. Here is a record definition duplicating the row structure of the category table. What is a record? A record is literally a structure which is very much the same as a structure definition in the C programming language, or really the structure of a table in terms of its columns and its data types. In this case, we've set type as being type name is a record, and we define the columns explicitly. In this case here, we defined and declared a record as being a copy of the column structure of the category table. Let's go more into record data types, because they're quite important when dealing with accessing database table rows from within PLSQL. Records actually allow step-by-step stepping through each row within the results of a select statement inside PLSQL. In this case, we're declaring, as with the category record declaration, a record which is a copy of the column structure of the ACT using ACT %row type. So the ACT %row type actually declared a record called RACT as a copy or an exact duplicate of the structure of an ACT row. In this case here, we're actually predefining our own type. This type happens to be called tshow for type show. It's declared as a record, and it contains a column which could originate in the show table, plus one that could originate in the venue table. Well, it does originate in the venue table since we declared it as being the same type as the venue.name field, plus we have an act name which is the same type as the act.name field. The point is we don't necessarily have to fill it with data which is a join of those three tables, that is, show, venue, and act. Now this is a type. Our act is a record. Here what we do is we declare a record variable as being of type tshow, which is of the type type. So creating the type creates a definition for a record, and here we actually create the record itself as against the data type tshow created by this type command. Let's go and look at some samples. Here I have an example of a record type with an anonymous procedure that doesn't do anything. Remember, null does absolutely nothing. Note that between begin and end there has to be at least one command, otherwise we will get a compilation error for this procedure. This code is exactly the same as the code I've just shown you, except it's in my script file. I'm going to copy and paste it and simply compile it and execute it in the database. Nothing happens because we say do null, which means do nothing. But we can see that it all compiles correctly, no errors come out. Let's go on to objects and object data types. There are various ways in which the object relational database can be implemented. Certain collection types or arrays, an array is really a sequential programming term for what in an object world would be a collection. A collection is a contained list which is contained within another object. Note that Oracle is a relational database. It is not an object database or an object structure. Be very careful using object structures in general in any relational database, because the two methodologies, that is relational and object, are totally different and they generally do not match or mesh very well with each other. Collections or arrays. In Oracle, we can create something called a nested table. A nested table is effectively a dynamic array. A dynamic array is an array which does not have specified start and end points, or more specifically, it does not have a specific size or a specific number of elements. It's a pointer. A V-array is a fixed length array. It has a fixed size. In other words, when you declare a V-array, you declare it as having a specific number of elements. If it goes over that number of elements, you will actually get an error or be required to extend the size of that V-array. An associative array is really another form of a nested table. It's actually an indexed dynamic array. It's a dynamic array with an index, which means that it can be accessed a little bit faster than a nested table if the nested table is large, and it can use an index to access a large amount of data with a small piece, that is an index, rather rapidly. Let's take a look at the syntax of various Oracle object collection definitions. A nested table is really a type. A type is in effect the same type of thing as a structure or a class. It's a definition for a tuple or an object. So here is the definition of a table. We simply declare a type as being of table with a structure within that table. This is a table which points to an undefined or dynamic array of varchar2 data types with 32 characters. And here, as I've said, a table is a pointer. I've declared it as being variable name pointer against that type, because that's what it effectively is. And here I've declared a V-array as having 100 elements, which are all integers. And here I've declared a variable against it. The same applies to an associative array. Note how each of these types has a variable declared against it. Again, the type is a structure or a class. It's basically an empty bucket or definitional type of code, piece of code, chunk of code, whatever you want to call it. You cannot use this type directly. You have to declare a variable against it. It's similar to the way that objects work in that you have to create an object in a class before you can actually put values in it, because the class is really the definition. A table structure is a definition. You can't really do much with a table until you put rows in it. The rows are the objects within the table structure. How do we reference collection elements? How do we reference nested tables, V-arrays and associative arrays? Generally, they are referenced using what is called in the object world typecasting. This is what a typecast looks like. What you do is you enclose an object within a class name. Then what happens is that the class definition and methods will be applied to that object in order to extract values from it or execute things on that object. Obviously, you can do multi-layers or multi-nested levels of typecasting. Typecasting can get really complicated, especially if you have very deep layers and you're accessing objects right from the bottom of a hierarchy up to the top. The deeper the layers are, the more complicated it is. It's probably the result of a structure which is too granular. Not necessarily, though. In the object world, a granular structure is an efficient structure in terms of coding. A very granular structure in the object world is good, but it is not necessarily an efficient form when executing. There's a big difference between objects when writing, developing and designing and when actually executing on a runtime basis. That is not necessarily the case, but more often than not. When referencing Oracle collection elements such as nested tables, V-arrays, and associative index arrays, there are certain built-in methods that can be used. The ones that are not directly obvious, I've annotated with a call-out box. Exists. Does an array element exist? A count is obviously a count of all the objects within that object, all the iterations of it. The limit is the maximum size of an array. First and last is the first and last object. Prior and next are methods which can be used to scroll through the objects declared. Extend will actually allow you to increase the length of an array, trim will decrease the length of an array, and delete will remove specific elements that you specify. There are code extensions within PLSQL which will allow you to more or less build class and method structures in much the same way that you can build properly designed object code within a tool such as Java or an object database. PLSQL uses specific constructor, member, mapping and order methods. I do not recommend trying to build object structures within PLSQL using constructor, member, map and order methods because of the simple reason that Oracle is a relational database. Once again, I'll reiterate, objects and relations do not mix well. The internal structure or the underlying structure is totally different. Object structures are extremely efficient for retrieving very small amounts of information, specifically when you know exactly what you're looking for from a very large set of data. Relational databases are not really efficient for doing that kind of thing. But relational databases have gone through years of development, and there are many bits and pieces on the outside of relational databases, such as highly efficient indexing, which can be used to find exact matches of data within large data sets. Object databases or object structures are very good at finding small pieces of data or exact matches within large sets. However, relational databases are extremely good and extremely excellent performers when it comes to writing reports. Because of the nature of the reports, reporting tends to denormalize a normalized or granular structure. Denormalizing an object structure is literally impossible. Running reports or creating data warehouse structures from object structures is going to be very, very difficult and could have an extreme impact on performance. One of the most crucial parts of the development of object relational databases, which are really object extensions in relational databases are large binary objects. These are called LOBs. There are different types of binary objects that you can use in an Oracle database. They're called blobs, clobs, etc. Various older versions such as raw types, which really stored binary data. They're very useful at storing images, sound files, multimedia, all that sort of thing. However, there's one very important point to note. In both relational and object databases, the most efficient way to store multimedia files is to store a pointer in the database and store the file externally. Unless that file is constantly changing, you do not need to store it in the database. There are a lot of utilities in Oracle which allow manipulation of binary objects and all sorts of other things that you can do with them. You can also store the binary objects in Oracle. You can even separate the storage structures between binary objects and normal relational tuple data. This can help to make the access of the two different types of data more efficient. The problem with binary objects stored in a relational database such as Oracle is that generally multimedia objects are very much larger than the size of standard SQL row data. The result is a lot of conflict between the amount of information retrieved and the amount of information or physical space needed to be searched to find individual rows. Now I want to look at some examples of Oracle collection objects. I'm going to look at nested tables, V-arrays, and associative arrays in general. First of all, let's do a simple declaration in an anonymous procedure of the types we had on the screen we saw earlier, just to make sure that the coding structure is correct, and it is. So we don't have a compiler problem there, so my syntax is correct there. Now, it's important to note that these types can be created on the fly in PLISQL, and they can also be created to be contained within Oracle database tables. I'm going to concentrate on the way that collections are used in tables. So first of all, I'm going to go and create a type. The type is actually a table or a dynamic array of varchar to 32 characters. Let's create my type. A type is really a separate database object inside the Oracle database. I'm actually going to go and alter my ACT table and add an object definition of that type I just created. It's a nested table, and with nested tables we have to declare it as a nested table and tell the database where to store it, because it is actually a table in itself. It's a table within a table, much like a one-to-many relationship. And now we've altered the table. Now, creating a table within a table really flies right in the face of any kind of relational database normalization and denormalization. As far as relational database design is concerned, this may or may not be a really bad thing to do. The point is you can't access this data from anywhere but within the ACT table. As far as relational database structure is concerned, that's not very healthy. I'll leave it to you to decide. Now I'm going to create another collection, which is not a nested table, but a V-array, which is a fixed length array. I'm now actually going to create another type which includes that skill collection type, so I've got a type within a type. And since I've created a type within a type, I have to create a type to cover that nested structure. See, it's starting to get complicated. Now, what we need to do is we need to add this cost collection type, which actually has the type tcost and a collection within it called skills. So we're going to add the cost collection type to the ACT table. Now we have all sorts of types. Let's go and add some data. I just want to show you how this is done syntactically. So I'm going to update the act table, and I'm going to set the equipment column, which is a definition of a collection, and I'm going to typecast it to the class name, and I'm going to add this list of values for one particular act. So let's copy and paste this, and I get that response, which is fine. I'm now going to do something on a slightly deeper layer. I'm going to add some data to the same act, but through the cast collection. And if you remember, I created two types, so I've actually got a cast type here in this class, and then a cast type in this class, and then within that a cast type of another class. Getting complicated. I hope you can see the point. In relational databases, creating objects is not the most efficient and not very simple to follow. It goes down to layers that are really deeper than they need to be. Mainly because it's a relational database. It's not an object structure, it's relational. The internal structure is based on table structures and rows rather than object hierarchies, which can be searched in any direction, to any point, and from any point. Now, let's go and look at that equipment update I did, this one here, and actually look at this data that I inserted for this particular act. This is what it looks like. It gives me the name of the class and all the items listed in that collection. What I really want to do is actually get that data out piece by piece. So I have to select everything from, typecast it through a table object because it's a nested table, and then execute the statement inside there. So let's execute it, and we get everything broken down into individual rows. 8 rows selected rather than a single row, typecasting through the name of the class. The next thing I want to do is I want to step by step break down all the parts and information in this triple layer typecast. So let's go and select the name and the cast object from that row, and I get something I can't see very well. So I'm going to set my column on this table to something nice and small so that I can see what's going on. Run it again. Here we go. Cast collection, tcast, and there's my other class at the end there. So let's break it down step by step. Now what I'm going to do is I'm going to pull out the things inside the tcast class. It's a nested table, so I decompose it that way. Now I could also set the column roll to have a very short format. And I could run that again, and I could actually see the values in the skills collection object collection. Now let's break it down further and go and have a look at the skills collection. And here I get the skills coming out. In order to see all the data within this skills collection, I would have to break it down to all its layers to actually pull the data out and list everything next to each other. What these really are all one-to-many relationships. From personal experience, I would definitely advise against mixing objects and relations at the database level. It is not a good idea. It generally leads to very poor performance, and it gets out of control very, very quickly. What do I mean by out of control? I mean inefficient, extremely inefficient, very poor performance, to the point where you could end up with either no job or a new product or a rewrite. Programming controls in PLSQL. Programming controls are really the controls in a programming language which allow you to communicate between different commands within a block of code. PLSQL has all the standard programming controls, namely an if statement, part of selection, a case statement, another type of selection statement, loop statements, a for loop, a while loop, and another type of loop which is really just called a loop end loop. A loop end loop can be either a while loop or an until loop. Sequence controls, which more sensible programming languages tend to avoid go-tos because they can persuade programmers sometimes to create really horrible, undecipherable, non-maintainable spaghetti code. Avoid go-to if possible. Null basically does nothing. You fill in gaps where you don't want absolutely nothing to be, like for instance inside a procedure that does nothing. A procedure doing nothing between a begin and end block will actually not compile, so you could put a null statement in there. Selection. Selection implies go and select one thing or another. This is the syntax for the if statement. It simply says if one expression is true, do something, else if a different expression, then do something else, and then the default, if all these options fail, is else, and you do something else as well. A case statement. There are two types of case statement. The first applies a search condition, and the second applies a selector and expression. Once again, it's a selection type of programming control. It selects something based on an expression or value. In this version of the case statements, the search condition simply says, when this condition is true, do this, when that's true, do that, and again you have a default at the end. The selector and expression sets up a selector which will evaluate to a result, and this expression 1 and expression 2 will actually contain the when clause that would be applied to the result of that expression. In other words, you say case, what if this happens, or a variable name, and you would actually have the value of the variable from the selector up there. Again, else for default. Iteration or looping. Here's the syntax of the for loop. Quite often for loops are syntactically different in every programming language. In Oracle PLSQL in particular, it just says for a value in lower value ... higher loop, exit when at the end or the beginning or wherever you like. Generally, if you use an exit when option in a for loop, you probably shouldn't be using a for loop. You should probably be using a while loop or simply a loop end loop statement. The while loop. Traditionally, a while loop has the test condition at the top of the loop. It says while a value is something, or while a state or a condition is true, keep going. An until loop, on the other hand, which is not specifically coded in Oracle PLSQL, would actually have the exit when expression at the end. In other words, it executes until a condition is true. Remember, while is the test at the top, until is the test at the bottom. They do have very specific applications, and any programmer will tell you that all these different types of programming constructs actually all get used under very specific circumstances. That's why they all exist. Here's the loop end loop statement. The loop end loop statement can behave, as it says here, as a while loop with the test at the top, or an until loop with the test at the bottom. While executes while a condition is true, test first. Until will execute until a condition is true, test at the bottom, or test last. Sequence controls. Go-to statements. Here's the syntax. If a condition is true, then go to a label. Down here, if a condition is true, go to a label. Label 1, label 2. I do not recommend using go-tos. Avoid using go-tos in programming languages, in any programming language, like the plague. You will end up with serious problems later on, unless you absolutely have to use go-tos. When I went to university, we were taught to program in a language called Modular 2, which absolutely did not allow the use of go-tos. It doesn't even exist as a statement in that language. The reason why was because every single programming problem can be solved without a go-to. It simply can. There is no argument against it. It does get complicated, but that's the way to do it. Everything is all about recursion and iteration. It's not about jumping from one point in a logical structure to another one any way you like. That's what ends up being spaghetti code. It is impossible to trace. It ends up with lots of chunks in there that may not be used. It just gets way too complicated over a period of time. If you have multiple programmers and multiple coders, they all have their different styles. Go-tos and use of go-tos will confuse everybody, and you will end up with a big problem eventually. Another sequence in Oracle is a null, the null statement. It simply does absolutely nothing. One good use for it is when you're trying to trap an exception and trying to stop that exception from being passed up to the calling block or calling procedure or application. Tell it to do nothing. All it will do is trap the exception and say, oh, I'm going to do nothing, and it will actually go back to the next line from where you started. Simple database access in PLSQL. What do I mean by simple? I mean single command database changes or access, such as a single select command plus insert, update and delete command. There is a very simple syntax change in PLSQL which changes the way the select statement actually looks syntactically as compared with SQL+. And it's very simple. All you do, as opposed to selecting values from a table in SQL+, all you do is select a list of values, columns, expressions into a list of variables. Obviously, within the PLSQL block, within the scope of the block, the variables must be declared. Additionally, as we've seen before, the returning clause can actually be used to pass values or rows of values into single variables or arrays. The returning clause applies to insert, update and delete and only applies in PLSQL. Let's take a look at some example code. I'm going to create a very simple procedure which contains one single SQL statement. As you can see, the syntax is select count everything into a variable name from a table. Let's declare this procedure, and since it's anonymous, it's going to run all by itself without me having to use the exec command. And that's got something to do with my buffers, so we'll just clear it and start again. And it tells me it's counted 59 acts in the database. Let's verify that. Select count from act, 59 rows. That's the answer I was looking for. Now let's go and try an example which selects multiple columns into multiple variables. So I'm going to once again copy and paste an anonymous procedure and run it in SQL+. What this procedure did was to select acts and names into those variables from the act table, and I restricted it to one row by setting the row number equal to 1. I can't output multiple rows into this type of syntax structure because I need to put it into an array structure, something such as a record. The result here was that I found the first row and it says the first act stored is number 1 and that person's name. Now what I want to do is to make use of the returning clause just to demonstrate its use. So I'm going to add some data, as it says here, where dependencies exist between following SQL commands. In this case, I'm using an insert table and returning values. I'm going to use those in the show insert. Namely, the act ID returned by the insert statement as being the next sequence number for the act sequence is passed into the insert for the show. This is probably more efficient than reaccessing the sequence again under current value to find that current act ID value. Also, we won't actually be precisely sure that it's the same act ID because somebody else could be running a procedure such as this or simply adding to the act table. Within a procedure such as this, because of multi-user activity on the database, there would be no way to access this act ID other than to go back into this record I have just inserted and find its ID in order to pass it into this insert statement. Therefore, this is the most effective way to ensure we get the exact value. We do not do an extra select statement, an extra database activity, and we don't conflict with other users and find the wrong IDs. So, the show insertion actually returns this into show date. What I'm doing with that is I'm actually outputting it plus the act name which was returned from the insert statement. I'm outputting it using a dbms command. So let's submit that procedure to SQL+, pass it and compile it. and it appears that we have an error. This is why. Because we added these nested table objects. At this stage I have two options. I could simply drop these columns, or I could simply set them to null. So, let's think about what we can do. We could actually adjust the insert statement in the procedure. Looking at the procedure, I can see a very simple way to adjust the procedure. What we'll do is we'll simply set these two collection objects to null, and we'll re-execute the procedure to add that particular record. So, paste it into SQL+, and it tells me that it added a show on that date for that person. So we could actually select everything from the show table, and the last record will be that particular show. So let's verify our data, and we say we have 64, which is Act ID 64. This is the show table we looked at, that's Act ID 64. And we'll look at the show table where the act is in the selection of act from act, where it is the act that we added. So, there we have it, show ID 156, etc., etc., etc. The answer is correct. Our procedure worked properly. What are cursors? What is a cursor? A cursor is a chunk or piece of memory allocated for the results of an SQL statement. When is a cursor created? In fact, a cursor, being a chunk of memory, is created every time any kind of SQL statement is executed. PLSQL cursors, on the other hand, are more specifically an area used to store the values for a select statement which selects more than one row. In PLSQL, a cursor can be used to scroll through all those rows one by one. In general, most cursors are implicit cursors. Since any select statement in SQL Plus or PLSQL or any tool that is used to access an Oracle database is a cursor, most of those cursors are implicit cursors. An implicit cursor is a cursor which, exactly as the word implies, it creates itself. An explicit cursor is one which is explicitly created in PLSQL by a programmer. What do cursors let you do? Specifically in PLSQL, they allow explicit searching through sets of rows on a row-by-row basis. In PLSQL, the explicit scrolling through rows with exact access to each row applies to both implicit and explicit cursors. So what is an implicit cursor? It's created automatically. There is an internal cursor contained within PLSQL called SQL. Access to the methods and types and values or constant values within this cursor will give you results or values which are applicable to the most recent statement or SQL statement executed within your session. Aside from that, one of the implicit cursors used in Oracle PLSQL is called a cursor for loop. Here's a script for cursors. First of all, this update statement is actually a cursor because it reserves an area of memory whilst it executes in order for storing the results of its execution. Oracle PLSQL allows access to certain attributes of the most recently executed cursor within this session. It happens to be, for this SQL %NotFound, it happens to be this update statement. When this update statement executes, we will get an answer from this cursor telling me whether this record was not found or not. If it wasn't found, it'll allow me to insert. Let's copy this procedure and execute it. Once again, we have the issue with the collection objects. So all we'll do is we'll simply go and edit this insert statement and change the act and put the two collections in and set them as null. Let's once again copy and paste and we see that this person has been added. Now, since I asked the update if it was found, now it will be found by the update, so it won't insert. So our message is different, changed to that, so it actually executed the update. Now if we go really crazy with it, she'll actually be added again because her name was changed, therefore her name is not there. If I happen to add it again, I get an error. Why? Because I'm trying to change from this one to this one. Well, this one to this one. It already exists, so it tells me I can't do it because the primary key is already there. Or a unique constraint, which is a unique constraint actually on the name field. I can't go and update that field there, which didn't exist before the insert, before the second insert, with this name because it's already there in another row. I can actually achieve the same result using what's called really embedded exception blocks and traps. So I could do the same update statement, and if it succeeds, it will drop to this next line. If this update does not succeed because it doesn't find the record, it will actually drop into the exception loop. However, there's a problem. The update statement does not produce this particular exception. So update failure will not be bounced to this trap. The thing we have to do is we have to put a select statement before it, because select will detect this. So this method actually is slightly more granular and perhaps a little bit better organized, but it has an extra line of code and an extra SQL statement. Now, since we actually already had a problem with this particular record and updating it, and we had a constraint error on a unique key, what I'm actually going to do is I'm going to roll back the previous changes I made. So now that data is not there anymore. This act is no longer in the act table. So I'm going to copy and paste this version, and I'm going to paste it in. Once again, this is my collection error on the act table. So I'm simply going to go into this insert statement, change the code here, and add these nulls again. The easiest way to correct the problem. So I'll copy and paste back in, I'll run the procedure, and it says she's added. Once again, it says she's changed, and once again, it says she's added, and again, I get the unique constraint error on the fourth execution. Now let's go and look at an example cursor for loop. What is a cursor for loop? A cursor for loop is an implicit cursor because it does not require explicit declaration of both cursor and the record acting on the cursor, plus explicit commands to tell the cursor to open, close, and require fetching of each row. All you do is you create the cursor as a definition in the declaration section, and then you loop through the cursor with the for loop. You don't even have to declare the record, which is this rShow thing, against the cursor, cshows. So let's simply just execute this cursor, and again we have the error. Okay, this is interesting. This is because I haven't set dbms output to 2000 characters. I haven't set the buffer limit. The limit of that buffer is 2000 bytes. 2000 characters, not very much. Doesn't take very long to fill it up. As long as you keep outputting, no matter what you do, as long as you keep the same session open, which I've had open for a while, eventually that buffer will overflow. So what I'm going to do is I'm going to first of all clear the buffer. I have to use the exec command because it's not in the procedure. And then I'm going to make it nice and big this time. The only problem with a large buffer, if I have limited memory on my machine, on my client machine, is going to fill up pretty fast. And that is 1,000,000 bytes. I count 6 zeros. Run the procedure again. There we go, lots of data coming out. All that procedure has done is really looped through all the show records, well, a join between venue, act, and show, and simply printed out the name of the venue, the name of the act, and the date on which that show occurred. And here's a description of the buffer overflow area. Obviously, when I was constructing these scripts, I came across the same error. Typically what you do when you run something in a procedure, including DBMS output, which I've shown you this before, is you set server output on, you enable the buffer, and then after disabling it, you set server output off. So let's just execute that again. It's useful to have these errors coming out because you are going to get errors like this, and if you haven't seen it before, you won't know what it means. And what I did there with output was I left the T out. So let's be insane about it and run it again. And there it's all working. Explicit cursors. What is an explicit cursor? Unlike an implicit cursor, which is declared automatically, an explicit cursor is declared by the programmer. An explicit cursor allows precise, row-by-row program control. By this we mean that an explicit cursor will allow explicit or specific access to each row in the cursor. Explicit cursors have certain requirements that the programmer is required to do in PLSQL. Explicit cursors must be, firstly, they must be declared, they have to be opened, each row must be fetched and processed row by row, and finally, when an explicit cursor is finished with, it must be closed. If an explicit cursor is not closed, eventually cursor limits will build up on the database, causing problems for the database administrator and ultimately performance problems. Explicit cursors can be created precisely with an exact SQL statement, or they can also be created generically, or sometimes referred to as dynamically. In other words, you can create a SQL statement in a PLSQL procedure where the SQL statement creates a cursor where the SQL code is generated on the fly. So for instance, you could have a procedure that passes a table parameter in that reads data from a different table depending on what the table parameter is. Obviously it must be a table parameter existing in a schema that is either your own schema or another schema that you have access to. Cursors can also be passed as biref parameters. Let's go and look at some examples of explicit cursors. I have three somewhat different cursor examples. These are not really complex cursors, but they should serve to show more or less how to build very simple explicit cursors. In the first example, I declare the cursor in the declaration section with a record which matches the structure of the cursor, which happens to be the structure of the ACT table. So my ACT table has an ACT ID and a name column. The record for this cursor is declared as being the row type of the ACT table. Now first of all, there's something I should do. If I describe the ACT table, I still have my equipment and cast object columns. I'm simply going to drop those columns for now. I've dropped the two extra object columns in the ACT table. What I'm going to do now is I'm going to copy the explicit cursors one by one into SQL Plus and execute them. First of all, we're using DBMS output. I'm actually going to set server output on, and I'm going to go and do this. I'm sizing the buffer for DBMS output to a very large value, as I may be dumping out a lot of information. So, the first cursor. We're declaring a cursor in the declare section. Here's a record. This matches the ACT table. Down here I'm going to explicitly open the ACT's or CActs cursor, I'm going to deliberately loop through each row found by the cursor, and after I'm finished I'm going to close it. Now since I'm not doing any SQL code which changes anything in the database, I don't need to do something like this. It's unnecessary, so I'll just comment it out for now. I could, however, place a raise command in here, which, in the case of any exceptions thrown, it will close the cursor, and it will raise the error up to the calling block, although I may not necessarily need to have that command in there because the exception is handled in here and I don't necessarily want to pass the error up to the calling block, which could be all the way back up to the application. Also note that I've actually got two lines in this procedure which close the cursor. When I go through this piece of code, once I get to the exception, if I haven't thrown an exception, my execution path will actually pass down to the end block. When an exception is thrown anywhere within these lines that are highlighted, it automatically jumps into the exception loop and executes this. So there is a possibility that I have opened the cursor and it hasn't reached this line and it jumps into the exception block. So I want to make sure I close the cursor. Remember, you have to close cursors, otherwise you can eventually cause problems with the database. There is a limit to how many cursors can be opened in an Oracle database at once. So, now let's go and copy our cursor and paste it in. And here's the result we get. What we actually did was we simply opened the cursor, looped through it, fetched each row from the cursor into the record. Remember, the record represents a single row. The cursor is actually, internally it's a pointer, but it represents the array of all the rows. I said, try to fetch. If I don't fetch, it's going to say exit when the cursor is not found. Remember, the internal cursor, SQL %not found, the same %not found value applies to any cursor which we create. When I don't find a record, it actually aborts the loop, closes the cursor, and exits the procedure. When I do find a row, I simply output the name of the act, which is what we have here. All the names of the acts in the act table. Let's go to our next example. What does this example do? It says this is for generic SQL, and you create the cursor like this. What I'm actually doing here, as opposed to the first example where I created a cursor and allocated the select statement to it in the declare section, I'm actually going to create the cursor and assign the select statement to it on the fly between the begin and end execution block, not in the declaration block. So the kind of cursor I create is a little bit different. It's actually something called a ref cursor. A ref cursor is purely a pointer. So in some respects, this kind of cursor, or this kind of explicit cursor, is something like a pre-allocated block of memory, or perhaps even a fixed array, if you like, and this type of explicit cursor is more of a pointer. In other words, a pointer to a chunk of memory rather than a large piece of reserved memory. It could be looked at like that. So, I declare a type which is actually a ref cursor, and it's actually duplicating the row type of the act table. I then declare a cursor against the type, and I then declare a record as being a copy of the column structure of the act table. I then open the cursor for the acts table with a select statement. And note that this select statement can actually be dynamic. So what do I do in this cursor? More or less the same as the previous example, except that I've simply moved the definition of the cursor select statement down into the procedural block. So let's simply take a copy of this procedure, and once again we'll just execute it. We have two coming out of there, namely two acts, because we only selected acts that started with C. Remember, the main difference between these first two examples is that this uses a simple cursor, or a simple explicit cursor, and this uses a ref cursor. Now let's take a look at my last example. What I'm actually going to do is I'm going to pass a parameter into a procedure which places a pattern into the select statement. Notice the only difference between this cursor and the previous one. So let's create and compile and pass this procedure, which we've done. We have no errors. And we'll go back and we'll execute it a few times using the exec command. And there we have it. 2 acts start with C, no acts start with null, and 1 act starts with A. Dynamic SQL. What is Dynamic SQL? Also known as generic SQL. Dynamic SQL is like any dynamic sort of code. It's generated at runtime, constructed at runtime. It's built based on the values of variables rather than an explicit string, so you could change a table name in a select statement, you could change a where clause, the values in the where clause, etc., etc. Dynamic SQL can be used for both DML and DDL commands, data manipulation language and data definition language commands. Commands which change data and change metadata respectively. Dynamic SQL can be used both inside and outside of procedures. In other words, Dynamic SQL can be executed within PLSQL blocks or in command line form in SQL+. The most efficient method of executing Dynamic SQL is using the execute immediate command. Execute immediate command is followed by a string enclosed in single quotes. The single quoted string contains the SQL, DML or DDL command. It's important to remember that you cannot execute DDL commands directly in PLSQL blocks. They have to be executed dynamically using something such as the execute immediate command. As I already said, you need explicit system privileges to execute whatever DDL commands you're executing. There is an older form of Dynamic SQL. Execute immediate, or the use of the execute immediate command, is now known as native Dynamic SQL. In the past, and still available now, a package called DBMS SQL was utilized to execute Dynamic SQL. The execute immediate command is much simpler and easier to use and is generally faster. So we won't be covering the DBMS SQL package, but it does exist. Now I want to go and take a quick look at some examples. Here's my first example. It says, let's count all the rows in all tables. First of all, what I'm doing is I'm setting up a cursor which reads the table name from my user tables view and orders it by table name. Then what I'm doing is I'm using an implicit cursor for loop to scroll through it, and then I'm using an execute immediate command to simply select the count of rows from each table. So I'm submitting this select count command from the table selected from the cursor into the rows variable using a Dynamic SQL, native Dynamic SQL execute immediate command, and then I'm going to output the number of rows using the output command. So let's copy and paste this into SQL Plus and execute it. Here's the result of my table count procedure. As you can see, these are my 3 divided up ticket tables, if you can remember when we did that. Here's the ticket table, supporting act, etc., etc. All nice and neatly laid out. The second example produces exactly the same result as the first. Although what I do here is I'm using a very large varchar2 variable called SQL code. I'm going to build the select statement into this variable, and then I'm going to simply execute immediate on the variable name into rows. So let's run that as well and make sure we get the same result, which we do. As you can see, the numbers are all the same. Generally, I remember the ticket row number result because it's very large. Another way to do row counts is a SQL Plus script, which I have here. All this does is really generate a SQL statement in the same way that execute immediate probably does internally. It pumps it out to a log file, this log file, namely count SQL, and then executes that log file. So we can run that quickly just to see what that looks like. But that's the equivalent of the table count procedure from PLISQL that I've just been running in 2 examples, and this is the SQL equivalent. And there we have it. So that's some example dynamic simple DML commands. Oracle provided packages, generally called DBMS underbar packages. I just want to go through a few of these packages, of which there are hundreds. I want to go through a few of them that I find useful on a day-to-day basis. Note that all these packages are really relevant to SQL and PLISQL. There are others that I would include in a database administration course, but that's for later. DBMS log allows you access to and manipulation of binary objects. DBMS output, we've seen quite a lot of, allows you to output text from within PLISQL blocks and procedures. DBMS redefinition. This package quite simply allows you to redefine tables online. In other words, whilst they're being used. DBMS SQL, we've already seen. DBMS SQL is a package which you can use to execute dynamic SQL statements, both DML and DDL. It's more or less being superseded by the execute immediate native dynamic SQL command. DBMS trace. That one should be obvious. UTL file, utility file. This procedure I have used fairly extensively in the past. It allows you to write information directly from inside the Oracle database out to the file system. However, there's a very special parameter that has to be set in the parameter file. You might want to ask your DBA about setting this parameter if you really absolutely need to use this procedure. The parameter set in the parameter file actually allows access to the disk through Oracle, so it can actually be quite a serious security issue.